Let's start off today reminding ourselves what we know about triangles. Remember, the whole idea behind trigonometry is connecting measuring angles with measuring lengths. You want to be able to measure angles and measure lengths. We need something to connect lengths and angles. Let's review what we know about triangles. So one of the things we know for all triangles is that the sum of the angles in a triangle is 180 degrees. That's one thing that we definitely know about all triangles. Over here, I've got a picture of a generic triangle, a generic right triangle. Another thing that we know about, something that we know about right triangles in particular is the Pythagorean theorem. This is a relationship between the sides in a right triangle. But in right triangles only, we get the Pythagorean theorem. The HM is going to be our abbreviation for theorem. I labeled this triangle with legs A and B and hypotenuse C. So we can summarize the Pythagorean theorem by saying A squared plus B squared is equal to C squared, as long as we remember that when we do this, C is the hypotenuse. C is the hypotenuse, which is opposite the right angle. Opposite means if we're standing in opposite an angle means if we're standing in an angle, we got our hands on the walls that make up that angle. I don't know why it's a room all of a sudden, it's a room all of a sudden. The side of the triangle that we are looking at is the side opposite that angle. Can't demonstrate here because we've got this rectangular room. If you give me a triangular room for trigonometry, it'd be pretty useful. And they're like, oh no, that is a terrible use of space. I was like, oh, come on, man. It doesn't have to be a right triangle. They're like, oh, Leach, that would make it. They're like, oh, Leach, that would make it worse. So here we are. So one of the things that we're going to want to have to do is name the angles in our triangle. So I've got this one labeled A, B, and C, where C is the hypotenuse because it is a right triangle. Sometimes what we do is we give the same letter name to an angle and a side when they're an opposite pair. So I might call this angle down here angle A. This is not great. Because if I say, what's A? Like, I don't know, is it capital A or is it lowercase a? You have to think, did he say the A really loud? Or was it just like a normal A? So this is A, and this is A, right? So that second one was clearly shouted because it's in all caps. Yeah, terrible. One thing, an alternate to this is to use lowercase Greek letters that correspond to A, B, and C. So instead of using a capital A for the angle opposite lowercase side A, and instead of using capital B for the angle opposite side B, and angle C for the angle opposite side C, we might give them Greek letter names. So I might call A angle A, angle alpha. Might call angle A, angle alpha. And so angle B, we might call angle beta. And we might call angle C, angle gamma. This is how I write those first three lowercase Greek letters. Alpha, I start at this end and loop around to make a little goldfish. I have a class during lunchtime, so it's going to be a lot of food references. I have to just deal with that. To make an angle beta, I start down low and I go up and then make a 3. So it's kind of like a very emo 3. It's like a 3, but it let its bangs grow really long. So it's like the bangs and the cycle, then you get to the 3. See it? Do you all see the emo 3? Do you? You might not have before, but now you do. Now try to unsee it. You're welcome. For gamma, I make it like an alpha, but rotate at 90 degrees. So I start on this side and kind of like make a goldfish diving down. I make too much loop on my lowercase gamma. And now all of you will make too much loop on your lowercase gamma. You're welcome. I do this because my trigonometry instructor made too much loop on his lowercase gamma. So now that we have these, we've got names for the 3 angles, we could summarize our sum of the angles in the triangle as alpha plus beta plus gamma is 180 degrees. The sum of the angles in a triangle is 180 degrees. The reason I want you to write this down is so you can practice writing alpha, beta, and gamma. But possibly you haven't done that very much. In a right triangle, if I use 90 degrees up to make a right angle, then I've only got 90 left for the other 2 angles. So the sum of the acute angles in a right triangle is 90 degrees. What's another word for sum is 90 degrees? Yes. Complementary. What's another word for sum is 180 degrees? Supplementary. So we have the acute angles in a right triangle are complementary. The angles of a triangle are supplementary. Sounds weird to say it that way, but it does. It's true. The angles of a triangle are supplementary. It's not going to fit, so I'm not going to write it. Also, some people might be like, well, you shouldn't say supplementary if you have more than 2 angles. So we do want to note that the acute angles, because we got 1 right angle, 2 acute angles. The acute angles in a right triangle will be complementary. The acute angles in a right triangle are complementary. How do I know the other two angles have to be acute angles? Yeah. Why would they have to be less than 90? Yeah. Total sum is 180. And if I use 90 of that 180 all in one angle, I've only got 90 for those other two angles. So those can't be bigger than 90. Otherwise, one of the angles has to be less than 0, and that's not okay. Not in this kind of geometry. So good. How's everybody okay? We had to introduce some other things. So I've got this A, B, and C. I've got the alpha, beta, and the gamma. We got one fact that's all angles, one fact that's all sides. So we needed to combine the two with our trigonometric functions. Sine, cosine, and tangent is where we connect angles, or we make a relationship between angles and sides. Yesterday, what we did was we named this angle on the floor of our triangle theta. And so that allowed us to identify a side opposite theta and a side adjacent to theta. Note that the side opposite theta, or opposite the angle alpha, is the side that's adjacent to beta. But I want to go back to theta because I want to remember our trig function definitions. So sine of theta is opposite over hypotenuse. What was cosine of theta? Adjacent over hypotenuse. And tangent of theta? Opposite over adjacent. Remember, it doesn't make sense to say opposite and adjacent without hypotenuse somewhere in the mix. Because otherwise an angle has two adjacent sides and we need to know which one we're talking about. So this tangent is opposite over adjacent only applies in right triangles. How's that okay? Are these the only three trig functions? Clearly the answer is no. You could tell by the way I asked the question, right? Are these the only three trig functions? I wouldn't have asked the question. I would have been like, oh, these are the only three trig functions, right? I would have been like, oh, are these the only three trig functions? No, there are other ones. The other three trig functions that we are going to mildly care about are just these flipped over. They're reciprocals of these. This raises a very important question. Why do we care about these reciprocal ones? It's like, well, in a modern setting, we don't, except for secant. Secant is closely related to tangent. We really care about secant. But cosecant and cotangent, the reason that we don't really care about them that much anymore is that we have machines that do calculations for us. So we don't really need all the trig functions. There are more than 6. But cosecant, abbreviated CSC, is hypotenuse over opposite. Notice that cosecant is just the reciprocal of sine, and it's abbreviated CSC for cosecant. Secant, abbreviated SEC, is hypotenuse over adjacent. This is just the secant function. Secant is the reciprocal of cosine. Cotangent, abbreviated COT, is adjacent over opposite cotangent is the reciprocal of tangent. For some of you, this will feel backwards. Why is cosecant the reciprocal of sine, while cosine is the reciprocal of secant? Cotangent is the reciprocal of tangent. Why didn't we just reciprocal the ones with and without the co? I don't know. I wasn't there. I missed that meeting when they decided to do this. Also, I've gotten through 25 years of career and 2 math degrees, not really needing to know what the other trig functions are. So I'm going to go out on a limb and say, you can probably not worry about it too much. You know what I mean? Did you know that when you do a subtraction problem, like A minus B, one of those things is called the minuend, the other one is called the subtrahend. Which one is which? If by your silence you mean, I don't know, I've never heard those terms, I don't either. And I have 2 degrees in math, so I don't think it's all that important. At least I hope. Any questions? I'm gonna put this on YouTube. Don't at me in the comments. It's because they can't at me in the comments. I turn comments off. Suck it, trolls. So we have, these are the 6 trig functions that we're going to run into a lot. The most important ones for our purposes right now are sine, cosine, and tangent. If you only got room for 4, make it secant. Like, oh, dude, I cannot have any, I can have one more. I'm like, oh, secant is the one. That is the one. You can live without the other. How's everybody okay? Was that? Still alive. Rad. So here's what we need to be able to do. One of the things that we want to notice is that the trig functions, sine, cosine, and tangent, are all represented as ratios of sides in a triangle. So notice that the trig functions are all ratios of sides in a triangle. There are other ways to think about trig functions, but this is the way we're going to start thinking about trig functions. So this is just where we're starting. We're starting with right triangle trigonometry. The reason I picked this is because I like this one. So if I have a triangle, like the triangle that I have up here with the sides, so I built this right triangle using a floor of 4 and a height of 3. We can use the Pythagorean theorem to figure out what the hypotenuse is. Hypotenuse squared is 4 squared plus 3 squared. Since the square of the hypotenuse is 25, that means the hypotenuse must be equal to the square root of 25, or 5. In a right triangle, I only have to tell you 2 of the sides. You can figure out what the third one is. I'm going to put theta in the normal place that we put theta. So I could write sine of theta is 3, the opposite, over 5. Cosine of theta is adjacent 4 over hypotenuse 5. Tangent of theta is opposite 3 over adjacent 4. We're just using trig functions on the sides of the triangle to figure out trig functions of the angle. The trig function of an angle will represent a ratio of sides. There's another acute angle in this right triangle. I can give it a different name. If you make a lowercase o and then put a vertical line through it, I'm not making an empty set. Make a little o and then a vertical line through it. That's a lowercase t, or sometimes we say phi. I could write trig functions relative to that angle. Notice that what is opposite theta is adjacent to phi. So if I write sine of phi, what fraction is that? Sine is opposite. So 4 was adjacent to theta, but it's opposite phi. So sine of phi is 4/5. Cosine of phi is adjacent over hypotenuse, or 3/5. Tangent of phi is opposite over adjacent, or 4/3. Any questions? Comment? Yes. Phi wouldn't be opposite theta. It would be complementary to theta. It's the other acute angle. Is that okay? We like labeling parts. So, of course, it's like when you get the IKEA furniture and you pull all the parts out, and you look at the page that has a picture of the parts and you make sure they all match up, right? Here's how we're going to start thinking about trig functions. Trig functions representing ratio of sides in a triangle. An important thing to note here is that although 3/5, that's easy to deal with, we know what that is. If we want to try to figure out what that angle is, we're going to need a machine to help us. Technically, we don't need a machine to help us. If we do this really old school, we could get a slide rule and figure it out that way. But if you want someone to show you how to use a slide rule, it's not going to be me, because I'm not that old, and I'm a little bit insulted if you thought I might be old enough to do that. The other way that this could be, that we used to do this, like I was there, I'm giving the game away. The other way this used to be done, take myself out of it, is that you used to carry a book of trig functions. And so when you're like, oh, what is if sine of theta is 3/5, what angle has a sine of 3/5? You'd like open up the book and look for 0.6 in the book somewhere. It's like, oh, there's 0.6. It is a 30-something degree angle. And you have to look that shit up in a book. But we have technology, which makes the process much simpler. So one last thing before we take a quick break and then do some practice. So on your calculator, you have 3 buttons: sine, cosine, and tangent. Sine, cosine, and tangent. They are abbreviated sine, cosine, and tangent. We don't want to just pronounce the abbreviations. On your phone calculator, I only have one kind of phone. On your phone calculator, I'm going to get a text now, I'm sure of it. You'll notice that you don't have sine, cosine, and tangent in this orientation. But if you turn your phone sideways, then it switches to scientific calculator mode. And there are your buttons: sine, cosine, and tangent. So if we want the way that your phone calculator will work, at least your iPhone calculator, I think your other calculator do the same, is you put in the angle that you want, because the button says, I'm going to do whatever function of whatever is on the screen. So if I put in 60 for a 60-degree angle and then press the sine button, that's the calculator doing, oops, I'm in radians, 60, and then press the sine button, that's the sine of 60 degrees. You have to put 60 and then hit the sine button. You don't hit equals or anything like that. The button says, I'm going to take the sine of whatever's on the screen. That make sense? So everybody, like on your phone calculator, put 60 and then hit the sine button to make sure you get 0.8660. Notice that I got something different when I tried it the first time. That's because my calculator was originally in radians. Clearly, these are the units that we used back in the 80s, and they're still around. So if we put a 60, now it's looking at 60 radians, not 60 degrees. And so if I do the sine, I get a different value. So if you got negative 0.304, you want to make sure you're in degrees so that the sine of 60 will be 0.8660, and then some other stuff. On your Texas Instruments calculator, the button works differently. Texas Instruments calculators and a lot of graphing calculators have a type it like you see it. I think some phone calculators have a type it like you see it strategy. So if I see sine of 60, I want to just hit the sine button, and it says ask for the angle after it. So this is a type it like you see it method. Any questions? How's that okay? Might seem like a lot to like go over how your calculator works, but the reason I'm doing this is that humans don't come pre-programmed with any apps. Well, actually, humans come pre-programmed with exactly one app. When you are hungry or cold or uncomfortable anyway, start screaming. That will fix the problem. That is the one thing that you know how to do when you are a brand new human. Like, I am uncomfortable, volume. That's it. You don't even know how to sleep. You can learn how to sleep, right? You've got one app. And it's a flow chart. It says, am uncomfortable? Yell. So. All right. Now notice that this has the angle. I said the angle already. What if we have backwards information? I want to know what the angle is. I've got the 3/5, that 0.6, but I don't want the sine of the angle. I want the angle itself. I have to undo. This has had 0.6 has had sine applied to the angle already. I want to undo that sine. So fortunately, our calculator has an answer for that. Above sine, on my calculator, it's written in blue. If you have an old school TI-83, it's going to be written in yellow. It's a second function for each button. Each button has to have more than one function, otherwise there'll be too many buttons. So to get that sine to the -1, it looks like it says sine to the -1. Not going to focus. I brought it to the camera. I'm like, I'll focus. Camera's like, I'll back off and then I'll focus. All right then. So to get those functions, I press second, and that gives me sine inverse. And I want the sine inverse of my 3/5. And that'll tell me how big the angle is. Sine of theta is the 3/5. So theta itself is the sine inverse of 3/5. So you press second sine to undo it. Just like the inverse of adding 2 is subtracting 2. So 5 plus 2. If I now take 7 and subtract 2, I'm back to where I started. If I do the sine of 50 degrees, it's 0.7660. And if I do the sine inverse of 0.7660, 444431, it gets us back to the 50 degrees. Any questions? Inverse trig functions to find angles. Inverse trig functions to find angles. Let's take a quick break, and then we'll come back and we will practice using our calculating machines. A few things before we start practice today. Your calculator, if you haven't used trig functions before, is probably in radian mode. So if you've got a Texas Instruments calculator, you're going to want to go into the mode with the mode button. And then there's one of the lines down here is between radians and degrees. So you highlight one, and now it's in radian mode. So if you want it in degree mode, you want to highlight degree and hit enter. And now your calculator is in degree mode. So make sure your calculator is in degree mode. On your phone calculator, there's probably a button. There's probably a button, like we saw earlier, either labeled rad, or it might be labeled deg. So for radians or degrees. So when the radians are active, it's a degree button. When degrees are active, it's a radian button. One thing to note is that the buttons on your iPhone calculator are sticky buttons. So if I hit second, it switches all these functions and they stay that way, even if I do some other stuff. I'm like, oh, what's the sine inverse of 0.6? It's 36.86. What's the cosine inverse of 4/5? They stay cosine inverse. Note that on the Texas Instruments calculator, if I press second sine and then do 3/5, it's if we want to access the cosine inverse, I have to press second again. So I have to switch the function to the cosine inverse. If I just try to press the cosine button, it'll just put the cosine button up. So second cosine inverse of 3/5, 53 degrees. Any questions? That's number one. So you use your inverse trig functions to find angles. Rather than if you can, you only want to press enter one time. You don't want to do a bunch of stuff in pieces. So like on my TI calculator, when I wanted the sine inverse of 3/5, I didn't figure out what 3/5 was first, then do the sine inverse of the result. I just did it all at once. Sine inverse of 3/5 for the divided by. I just use the divide by key. That's my over key. Then I hit close parentheses. And then I hit enter. So just do it all at once. We don't really get to do that on our iPhones. Well, we can. If we want to do the sine inverse of 3/5, we can use parentheses buttons. But sometimes we get lost and we have to remember where we're at in the calculation. But we can do like, oh, right, we don't press sine first anyway. We don't need them. We need to figure out what 3/5 is first. So we do 3 divided by 5. It's 0.6, and then we can do the sine inverse. Any questions? Now that I'm thinking of it, I press parentheses, 3 divided by 5, close parentheses, sine inverse. The parentheses just do the operation before we hit sine inverse. If you forget to do the 3/5 first, your calculator is going to try to take the sine inverse of 5. If I just try to press sine inverse now, I'm going to get an error because the calculator is trying to do the sine inverse of 5. And there is no angle with a sine that's equal to 5. Any questions? All right. With that in mind, we are going to do some practice. This is just practice using our calculator, getting used to pressing the right buttons on our calculator. Oh, another thing to note. Some of the problems on our practice today involve cosecant, secant, and tangent. And you'll notice that on your calculator, you do not have cosecant, secant, and tangent buttons. Cosecant is the reciprocal or of 1 over x of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So at some point, you're going to have to figure out where you flip things over. Your calculator does have a flip stuff over button. It says an x to the minus 1 on your Texas Instruments calculator. So if I do 5 to the negative 1, it gives me 0.2. That's 1 over 5. That's my reciprocal button. So if I do 2/3 is 0.6667. If I flip that over, I get 1.5, which is 3 over 2. So that x to the minus 1 button is a reciprocal button. Your iPhone uses a different button. Your iPhone has a button here that says 1 over x. It's a reciprocal. So if I do 5, oops, if I press 5 and then hit 1 over x, it gives me the reciprocal of 5. So you're going to have to figure out when you flip things over and when do you do the trig function button. Any questions? I could tell you, but that would ruin the game. All right. So here are the problems. And then we will sort into in-person breakout. The problems won't take long individually, but to get out today, we all have to do all of them. All right, I'm gonna pause the recording and we're gonna switch to practice mode.